Hello, students. Welcome back to the class. And a small recap or whatever we did in our previous class, just a small recalling about what is it. We studied about the velocity of a particle executing simple harmonic motion and acceleration, and also we derived the expression for velocity and acceleration, and we studied about the force law and gave you the expression for force law, isn't it? So, and also I had given you a brief introduction about total energy during simple harmonic motion. I had given you about a introduction or explanation about the total energy during simple harmonic motion. So what is that energy? Okay, so total energy ಅಂತಂದ್ರೆ ಏನು? So you might have heard about conservation of energy, where your total energy is equal to addition of or both together. What is that both? It is kinetic energy as well as potential energy together makes a total energy. So yes, during a simple harmonic motion, a particle executing a simple harmonic motion has got energy, that has a total energy. So now if I consider a spring or a pendulum, if I consider what would happen, it starts moving in this way. So I told you when it comes to the end, extreme end, it has got a potential energy ಅಂತಂದರೆ ಆ ಟು ಎಕ್ಸ್ಟ್ರೀಮ್ ಎಂಡ್ಸ್ನಲ್ಲಿ ಎಸ್ it is at rest. A particle comes to rest during what? During its extreme point. At that time I can say that the particle has its potential energy. Now if I consider a kinetic energy, excluding ಅಂತಂದರೆ ಅದನ್ನ ಬಿಟ್ಟು, okay, the extreme point, the movement, during its movement a particle possesses, or if I consider the pendulum, yes, it possesses kinetic energy. So now while deriving total energy during simple harmonic motion, first let me take a kinetic energy, and then let me derive for the potential energy. Now if I consider a kinetic energy of a particle executing simple harmonic motion with velocity v is given by, so what is a kinetic energy given? Yes, a k E, that is kinetic energy, is equals to 1 by 2 mv square. This is the very famous formula you'll be knowing and you'll be applying in every theories or derivations or something. So if I consider this kinetic theories formula, half m, that is mass, v is your velocity. So if I consider the next step, what is it? Oh god, you have got something very big, and how did this come is very important. So half, as it is, ಏನು half ಇದೆ, ಈ equation ನಲ್ಲೂ half ಇದೆ, m is here, and what is the extra thing substituted is v. So we have calculated in our previous class the value for velocity, that is v is equals to a omega cos omega t. Yes or no? So what am I going to do? I'm substituting the value of v here. So square is there, square it. So you get half m a square omega square cos square omega t. Now this is your value of kinetic energy. Please keep it in your mind. Kinetic energy's value would be, after substituting the value of velocity, you would get your kinetic energy would be so much. You have to remember. Next, going to your potential energy. So you might see here the work done to move the particle. So you can see here the work done to move the particle from the mean position to the extreme position is restored. Howda ಏನಂತ ಇದ್ದಾರೆ ಇಲ್ಲಿ? There is a restoration happening. So what is that restoration, and how did your potential energy become half k y square ಏನಿದು k y square ಏನಕ್ಕಾಯಿತು. Okay, now if I consider a spring, okay, so there is a restoring force in it. So idu spring constant or spring the formula. Okay, so why have given you this formula? Because always remember, if I consider your pendulum, it starts moving when it comes to your extreme end. I have told you at that point, the particle possesses potential energy. That potential energy, when it goes to its extreme point, what would happen? That itself produces a restoring force to come back. ಸೊ ಏನಾಗ್ತಾ ಇದೆ ಅಲ್ಲಿ, that potential energy is producing a restoring force, and that is why you can see I have used this formula, that is potential energy is equals to half. What is k? It is a force constant ಅಂತಂದರೆ ನಾನು ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ಲಿ ನೀವು ನೋಡಿದಂಗೆ ಐ ಕ್ಯಾನ್ ಸೇ k is a spring constant ಅಂತ ಹೇಳ್ಬೋದು. So k is a force constant as well as a spring constant, which is producing a restoring force. So that is why my potential energy would be PE is equals to half k y square. The y, that is your displacement, right? So now what would, oh, sorry, children. So in this slide, you can see that this equation, it has come mistakenly. So do not consider this equation and jump onto this equation. Okay. So now, what is k here? Okay. Substituting the value for k. I would repeat. Forget about this. Just do not consider this. This is the extra equation which has come during the typing. And so consider this equation. So half is equals to half. What is this? The value of k. ಈ k ವ್ಯಾಲ್ಯೂಗೆ ನಾನು ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ? What is the value of k we have calculated during our calculation for force constant? That is k is equals to omega square into m. ಹೌದಲ್ವಾ? ಸೊ ನಾವು ಏನು ಮಾಡ್ತಿದ್ದೀವಿ, ಇದನ್ನು ಕೆ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ಆ್ಯಂಡ್ ವಾಟ್ ಈಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ವೈ ಹಿಯರ್? ಇಟ್ ಈಸ್ ಅ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ರೈಟ್ ಚಿಲ್ಡ್ರನ್? ಸೊ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಏನು ಕೊಟ್ಟಿದ್ದೆ? ಟೇಕ್ ಔಟ್ ಯುವರ್ ನೋಟ್ಸ್ or go to the previous lecture and see what is the formula for displacement, and y would be equal to a sin omega t. So square ಇದೆ, so square ನ ಹಾಕೊಳ್ತೀವಿ. So you can see the square here. So square will remain the same. And what am I doing here? I am repeating the same thing whatever I have done in my kinetic energy, that is half is there. Okay, half is there, and here m. So if I consider this equation, m is common, omega square, and I am squaring the remaining thing, a square sine square omega t anta. Now if I consider kinetic energy and potential energy, you can see in common that half m omega square, a square is common. So ಇಲ್ಲಿ ನೀವು ನೋಡಿದ್ರೆ ಇಲ್ಲೂ half m a square omega square is common. And what are the different things you can see here? Is cos square omega t ಮತ್ತೆ sin square omega t you can find which is different. So now we got the formula for kinetic energy and potential energy. And what is that we are going to do here to find? What is our aim to do in this derivation? To find the total energy. So if I consider the total energy, I told you you're adding two different energies, that is kinetic energy and the potential energy. Now adding these two, what would you get? What is common? I told you half m a square omega square is common. And now what would happen? What is remaining? Cos square omega t sin square omega t. And there's a formula in your trigonometry, that is cos square theta plus sin square theta is equals to 1 ಅಂತಂದರೆ omega t, here omega t is considered it to be as theta, and following this formula I would consider that to be as 1. So taking common, ಏನಾಗುತ್ತೆ? Total energy is equals to half m omega square a square, and this is the expression for your total energy. And coming to the conclusion that total energy during simple harmonic motion is directly proportional. ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ? It is directly proportional to the square of the amplitude value. See children, you may think ma'am, different previous slides, previous lectures ನಲ್ಲಿ ಮ್ಯಾಮ್ told that amplitude ಅಂತಂದರೆ ಏನಾಗಿರುತ್ತೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಆಗಿರುತ್ತೆ. ಬಟ್ without taking amplitude as constant, why has she again put it in this equation or in this expression? See children, if only amplitude is there, ಬರೀ amplitude a ಅಂತ ಇದ್ದರೆ ಅದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಆದರೆ ಇಲ್ಲಿ ಏನು ಬಂದಿದೆ ನಿಮಗೆ ಫಾರ್ಮುಲಾನಲ್ಲಿ? ಎ ಸ್ಕ್ವೇರ್ ಬಂದುಬಿಟ್ಟಿದೆ, ಹೌದಲ್ಲ? ಸೊ ಇಲ್ಲಿ ಏನು ಬಂದಿದೆ ನಿಮಗೆ, ಇಲ್ಲಿ ಗಮನಿಸ್ಬೋದು, ಡಿರೈವ್ ಮಾಡ್ತಾ ಇರ್ಬೇಕಾದ್ರೆ ಎ ಸ್ಕ್ವೇರ್ ಬಂದಿದೆ ನಿಮಗೆ, ರೈಟ್? ಸೊ ವೆನ್ ಇಟ್ ಇಸ್ ಎ ಸ್ಕ್ವೇರ್, ಇಫ್ ಇಟ್ ಈಸ್ ಓನ್ಲಿ ಎ, ಅದನ್ನ ಕಾಮನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತೊಗೊಬಿಡ್ತೀವಿ. ಓಕೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಅಂತಲೇ ಅಷ್ಟೇ ಅಂತ ಹೇಳಿ. ಬಟ್ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಸಿ ದ್ಯಾಟ್ ಇಟ್ ಈಸ್ ಎ ಸ್ಕ್ವೇರ್. ಆ್ಯಂಡ್ ಆಲ್ವೇಸ್ ರಿಮೆಂಬರ್, ಯೋರ್ ಟೋಟಲ್ ಎನರ್ಜಿ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಯೋರ್ square of the amplitude. And why is it? Half is common, mass of any of the object remains constant, and angular velocity ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ ಯಾವಾಗ? ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನಲ್ಲಿ. ಸೊ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಆದರೆ ಇಲ್ಲಿ ಬರೀ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಇಲ್ಲ, ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಎ ಸ್ಕ್ವೇರ್ ಇದೆ. ಸೊ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್. Now going to the next topic, that is time period of oscillation for load spring. So you may think, what is this? Again about spring only ma'am is speaking. No, why not simple harmonic motion? And the first you have to learn about the loaded spring ಬಗ್ಗೆ ಕಲಿತ್ರೆ ನೆಕ್ಸ್ಟ್ ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್ ಬಗ್ಗೆ ಕಲಿಯೋದಕ್ಕೆ ಸುಲಭ ಆಗುತ್ತೆ. Now considering the time period of oscillation for a loaded spring. So what am I going to do? I'm finding the time period. ಎಷ್ಟು ಟೈಮ್ ಬೇಕು ಫಾರ್ ಅ ಲೋಡೆಡ್ ಸ್ಪ್ರಿಂಗ್ ಟು ಆಸಿಲೇಟ್ ಅಂತ ಹೇಳಿ. ಅಂದರೆ ಅದಕ್ಕೊಂದು ಫಾರ್ಮುಲಾನ ನಾವು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಮೂಲಕ ತಗೊಬರ್ತಾ ಇದ್ದೀವಿ. ಸೊ ನಾವು you can see here, consider a mass. So what am I considering? A mass m. You can see m attached to the spring of constant. So constant ಏನಿದೆ? k. ಆಯಿತಾ? ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಹೌ ಮಚ್ ಸ್ಟಿಫ್ ಇಟ್ ಈಸ್ ಅಂತ ಹೇಳಿ ಗೊತ್ತಾಗ್ತಿದೆಯಾ? ಸೊ ದ ರೀಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಆ್ಯಟ್ ದ ಸ್ಪ್ರಿಂಗ್. ಸೊ ಎಷ್ಟು ರೀಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್, what is the force acting on the spring? So ಹೌದಲ್ವಾ, what is that restoring force? So whenever I upload or give certain mass to a spring, what would happen? There is a restoring force. So ಅದು ಏನು ಮಾಡ್ತಿದೆ, that spring is trying to come back to its original size or shape. So that is your restoring force. And if I consider the formula for that, you can see F is equals to minus k y. ಏನದು F ಅಂತಂದರೆ ಫೋರ್ಸ್, k is your spring constant and y is your displacement. ಸೊ kನ ತೆಗೆದುಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ? ಪ್ರಪೋರ್ಷನಾಲಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಬರುತ್ತೆ, ಹೌದಲ್ವಾ? ಸೊ F is directly proportional to displacement ಆಗಲ್ವಾ? ಹೌದು. ಸೊ ಮೋರ್ ದ ಫೋರ್ಸ್ ಮೋರ್ ದ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ರೈಟ್? ಸೊ ಮೋರ್ ದ ಫೋರ್ಸ್ ಅಂತಲೇ ಜಾಸ್ತಿ ಮಾಸ್ ಹಾಕಿದ್ರೆ ತಾನೇ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆಗೋದು. ಸೊ ವಾಟ್ ಈಸ್ ದ್ಯಾಟ್? ಮೋರ್ ದ force, more the displacement. Now from the Newton's second law, what is that you're getting? It is F is equals to mass into acceleration. Yes, everybody knows that is equation 2. So from equation 1 and equation 2 now ಬರಿಬೋದು, it is minus k ಅಂತಂದರೆ F and F is there. ಸೊ ರಿಮೈನಿಂಗ್ ವಾಟ್ ಎವರ್ ದ ಥಿಂಗ್ಸ್ ಆರ್ ದೇರ್ ಅದನ್ನು ಕಾಮನಾಗಿ ತಗೊಳ್ಳಿ ಇಲ್ಲಿ. ಸೊ ರೈಟ್, ಮೈನಸ್ ಕೆ ವೈ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎಮ್ ಎ ಅಂತ ಹಾಕಿ. ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಫಾರ್ ಯುವರ್ ಆಕ್ಸಿಲರೇಷನ್. ಸೊ ಫಸ್ಟು ನಾವು ಟೈಮ್ ಪೀರಿಯಡ್ ಕಂಡುಹಿಡಿಬೇಕು. ಸೊ ನಾವು ಏನು ಮಾಡ್ತಿದ್ದೀವಿ, ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ? ದಟ್ ಐ ನೀಡ್ ಆಕ್ಸಿಲರೇಷನ್ ನೌ. ಓಕೆ, ಸೊ ಎ I would take it as it is. I am rearranging this above equation and I would get minus k by m into y. Now this I would consider it to be as equation 3. Next, going to acceleration during, ಏನು ಕೇಳ್ತಾ ಇದೆ? It is acceleration during simple harmonic motion. So what is it? A is equals to minus omega square y, right? So this is the acceleration we derived, isn't it, for the simple harmonic motion. So I'm taking both equation 3 and equation 4. Now what would happen, equating both equation 3 and equation 4, what would I get? So I would get minus omega square y is equals to minus k by m into y. Now I require omega here, angular velocity ನನಗೆ ಬೇಕು. So what would I do? I would rearrange this equation and I would put omega is equals to root k by m. ಆಯ್ತಾ? K is your spring constant or force constant and divided by m ಅಂತ ಆಗಿರುತ್ತೆ. Now remember, so what is your omega? Obviously you know that ಒಮೆಗಾಗೆ ವ್ಯಾಲ್ಯೂ ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. in your previous chapters of your first PUC you might have studied omega is equals to 2 pi f ಅಂತ ಹೇಳಿ. Now if I consider f, what is f here? How is f, that is your frequency, related to your time period? It is f is equals to 1 by t, right? So f ಅಂತಂದ್ರೆ f is equals to 1 by t time. So what am I doing? I am substituting 1 by t in the place of f and I would write omega is equals to 2 pi by t. Okay, now what am I doing? I am substituting this omega's value in this equation. ಈ ಈಕ್ವೇಷನ್ನಲ್ಲಿ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಅಂತಂದರೆ ಈಕ್ವೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಎರಡನ್ನೂ. ಓಕೆ, ಸೊ ನಾವು ವಾಟ್ ವುಡ್ ಐ ಗೆಟ್? ಸೊ ಇದನ್ನು ನಾನು ಈ ಪ್ಲೇಸ್ನಲ್ಲಿ ಹಾಕಿದಾಗ ಐ ವುಡ್ ಗೆಟ್ 2 pi by t is equals to root k by m. Okay, now sorry children, forget about this statement. And now what is the thing you would get? It is t is equals to 2 pi root m by k. So what is it? You're rearranging, and what is the thing you have to get? In target now it is to calculate the time period, right? So what am I doing? I am taking this equation and rearranging it to get the time, that is t. So t ಗೆ ನಾನು rearrange ಮಾಡ್ತೀನಿ. t na one side I would keep, and what would you get finally? It is equal to 2 pi root m by k. So this is the value of your time period for oscillation for loaded spring. So in the next class children, I would be deriving or deducing an expression you can see here for the time period of oscillation of a simple pendulum, which is very important, and you would get it for 5 marks, and which is very important in the point of view. What point of view? That is how you acquire your knowledge about oscillation. So the basic thing, whatever you have to learn, is hidden in this expression or the derivation. So hope I made it very clear to you of this class, and let me meet you in the next class children. Thank you.